Hello. How are we doing? It's good. It's Friday. I'm happy it's Friday. We're going to take a breath today for a moment and do just like a little bit of housekeeping stuff to start with. First of all, I have these little sheets and I'm starting to learn your names because mainly the reason I do these is it actually causes me to move your picture around in a Word document. And by moving it around in a Word document, I start to learn people's faces and names. So you guys are going to take a moment and fill this out for me. And I'm just going to check and see if anyone else has arrived. Are we out of seats for you now? Have they banished you? No. Okay, we'll see if we can sort something out now. You just picked it out? Okay. Armin is not back yet, right? Not Armand, Armin, yes? But Yovis here. Just feeling anything that is missing or incorrect. Okay, and Aaron is over here. Here we go. Elliot. Oh, he can be here, but he's not here. Alvin with the E, not Alvin with the A. Not yet. We have Aaron. Alvin, now we have Alvin with an A. Adriana. Where's Chloe? There you are. When you are done, there's this little black thing sitting in the middle of my demo table here. Okay. Thank you, Matthew. Oh, there's a back to it as well. Just make sure you've taken a look at that. I know some people missed it in my junior grades. Thank you. Thank you. I will get you on our team for this so you have access to all the resources. This is the big black book. This is what you had stuff in from the summer, okay? Some of you already have a physical copy of it. Sometimes it's just nice to have something physical. I don't actually tend to use it a lot. However, it is an excellent source of extra problems for things if you are interested. However, it is up on Schoology, of course, but I'll also be posting it up on Teams, so you don't have to, go back to Schoology if that traumatized you over the summer, okay? Although you might still have one for grade 12 there, I don't know. No, I think I've sorted myself on grade 12. Okay, is there anyone who would like a physical copy of this who doesn't already have one? Those of you who are walking around with a pile of heavy textbooks are like, no, God help me, I do not want another big heavy textbook. I'm so sorry, psychology and biology. So you do not have to have that, yes? Yes. It is 27. So a lot of people have been asking me about 5.1C, I think it is. Thank you. Thank you. So, my friends, anyone still filling in their sheets? I'll give you a minute. Take your time. Well, I'll stare at you while you do it. No, I'm kidding. Thank you. So I had some leftover copies of this document. This is what my grade 9s do after their third unit of chemistry, because you know me, I'm like a chemistry teacher. We do 3 chemistry units in grade 9. And this is sort of like all the particles that I expect and mixtures and various things that I expect my grade 9s to know. Now, you might take a look at this and be like, I know all of these already, that's fantastic, but it's here just to be a little reminder for you, a little pictorial reminder of things. So maybe over the weekend you could take a look at it, please, and make sure. The only one that's probably not going to affect you is the dot and cross diagram. We will not be drawing Bohr models this year to speak of, okay? So the dot and cross diagram, that's that very last one. Don't worry about that too much. We will be doing a similar thing, but with Lewis structures instead. Okay, but I was like, I have this. Oh my gosh, let's just print out copies for you guys because it will be helpful. So take a look at it over the weekend. Let me know if there's anything that is confusing to you or that you haven't heard of before. Okay? On page 9, 5.1c, everyone has pointed out to me that yes, I typed 21 as the power of 10, and it should have been 27. So in general, if everyone is saying it's something else, it's probably me that's incorrect. So if you're checking with your friends, it's probably me that's wrong. Okay? Other than that, were there any questions from anything that you did for homework? Okay, excellent. So I just wanted to make sure that everybody, when you are writing an ion, what must you include? The charge. If it's an ion, it must have the charge, okay? If I was to write, here, let's go to an actual page here. If I was to write SO2, does that contain ions? Sulfur is a nonmetal. Oxygen is a nonmetal. So when you have the two of those together, what type of bond forms? And therefore, what happens to the electrons? The electrons are shared, and so nobody gives away an electron and becomes positive, and nobody takes an electron and becomes negative. And so if nobody's giving and nobody's taking, if they're sharing instead, nobody becomes positive or negative, okay? Okay, and the reason for that is that nonmetals are electron loving. That's not the term we're going to use, okay? Nonmetals are electron loving. We are going to say, instead of electron loving, we're going to say the word they are very electronegative, okay? And if you're very electronegative, you pull electrons towards yourself. Oh, I forgot a T, electronegative. Electronegative, there we go, that's better. And this means they pull electrons towards themselves. We'll worry about why a little bit later, okay? But nonmetals in general are very electronegative. They pull electrons towards themselves. So if you have two things that are pulling on electrons, let's say this is an electron, and who wants to be my electron partner? Excellent. Okay, you have an electron? Oh, excellent. Daniel has an electron, and I have an electron, and we are both non-metals, so we both like pulling electrons towards ourselves. So I'm like, oh, I have a gap in my outer shell. You remember that from last year? Gaps in the outer shell. I would like to fill that gap. Oh, excellent. Yes? But I'm pulling on this electron, but he's another non-metal, so what are you doing? He's also pulling on this electron. Is your outer shell full? No. So what are you going to do? You're going to grab that, and because we are both electronegative, we both pull on those electrons, and nobody gives them, nobody takes them, we both just pull and hold them. And it is the nucleus, which is positive, that attracts the negative electrons, and the nucleus, which is positive, which attracts the negative electrons. Is that part of this unit? No. Okay? It never is, I know. So nonmetals are very electron-loving. Metals are not very electronegative. So they, oh my God, I cannot spell anything this afternoon. There we go. First, I didn't have it. It was because I didn't have it the first time. I needed to make up for it the second time. Sorry, question? They are actually electropositive, yes. We don't use the term the only thing is we don't actually use the term electropositive commonly, but it is in fact the case that they are electropositive, okay? So SO2 is not made of ions. How about is K2O made of ions? Yes. Okay. Why? Why is it made of ions? K is a metal. It does not hold on to electrons well. It has a low, what's the word? Electronegativity. Eventually, we're just going to write EN because that's one hell of a long word, yes? But for now, I'm going to write out the whole thing because apparently I can't spell it, so maybe you need some practice as well. I certainly do. Electronegativity. Oh, I got the number of T's right. Negativity. O. O is a nonmetal. So it does pull on electrons really well. So it has a high. And now I'm just going to call it En, electronegativity. So let's look at what happens with K and O. If we look at our periodic table, do I have a periodic table? Let me steal one from Science 9 somewhere. Yes? Like if you were to take the average of all the covalent bonds and the average of all the ionic bonds and their strengths, on average, covalent bonds are probably slightly stronger. However, there are ionic bonds that are stronger than some covalent bonds, and some covalent bonds that are weaker than some ionic bonds. But in general, we just say that covalent bonds are strong, ionic bonds are strong, and there was a third type of force that we talked about that was weak. Those are our intermolecular forces, and those ones were weak. Let's just write that down before I forget. So ionic bonds are strong covalent bonds, strong covalent bonds are, there are the strongest bonds are covalent bonds, but there are ionic bonds that are stronger than some covalent bonds. Like if you pick the strongest of all the covalent bonds, that will be the strongest bond. But there's also weaker covalent bonds. Within the range of covalent bonds, there's like a degree of strength. Okay, and we will look at those strengths and how they overlap and so on. But for now, just say they're strong and consider them about equal, okay? Whereas those intermolecular forces, which we can abbreviate as IMFs, they are weak. There is a third type of bond, like an actual bond. You'll notice that the forces are called forces and not bonds. There's a third type of bond that we haven't touched on yet. Does anyone know what it is? Metallic. Not yet, anyway. Okay, but they are also strong, and that's all I'm going to mention about them right now is that they're strong. Now, ionic bonds are made metal plus non-metal. Covalent bonds are non-metal plus non-metal. And metallic bonds are metal plus metal. And those are happening just within, like if you have a piece of copper, this copper atom sticks to that copper atom by metallic bonds. Okay? We'll worry about how those happen a little later on. If you have an iron atom that's in some stainless steel, there's probably chromium in here as well. So you have iron atoms sticking to iron atoms sticking to chromium atoms, and so on. And those are all going to also be metallic bonds. Okay. Questions? Okay. So those are our general kinds of bonds. We were going to take a look at a periodic table. Feel free to write all over your own periodic table. If you want another blank one, I will give you another blank one, okay? And that was here. Okay. Now on your periodic table, what you might notice is that, why did I come here? I can't quite remember. So we're going to, oh, I do remember. Okay. No, I don't. Yes, I do. Yeah, we were talking about potassium. Where is potassium? Potassium is here. What kind of an element is that? It is a metal, and specifically, what group does it belong to? The alkali metals. And what do you know about alkali metals? Yes? Pardon me? They're really reactive, okay? Nope, not that. Okay, so they're really reactive. And if I was to draw a Bohr model, and don't you draw the Bohr models because this will drive you crazy, but we would have lithium. How many electrons would be on the first shell? 2. Do they go apart or together? Together. Sometimes you will see them drawn apart. Doesn't matter, you're not going to be drawing Bohr models anyway. Okay, you with me? Okay, so don't worry about the details of the Bohr model. The reason that we're drawing them together is it is more accurate to how those electrons are actually paired together in an orbital that we will learn about later, okay? Huh? Don't worry about it. It's all good. Just let it go by. Yeah, well, okay. He's a physics teacher, not a chemistry teacher. Okay. That's okay. Our department head used to be we used to have a department head like several years ago. He's now a vice principal somewhere. And he would teach the students, he'd be like, brackets. If you have a polyatomic ion, just throw brackets around it. It doesn't matter if there's 1 or 2. And Ms. Wu and I are like, what? What are you teaching them? So we used to give him a really hard time. He could take it though. So lithium has 3 electrons, and so the third one's going to go here. Now we would have, after lithium, who comes next? Sodium. And sodium would have its full inner shell. Quite frankly, how you draw the inner shell is unimportant. It's really the outer, like after you get through number 1, that matters, okay? If I were to draw this, I would draw it this way. I would say, there's 1, 2, 3. How many electrons does sodium have, by the way? Tell your partner. How do you know? How do you know it has 11? That's its atomic number, yes, okay? 1, 2, 3, 4, 5, 6. Where does the 7th go? So 7, 8. No, hang on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we have 11. It actually doesn't matter whether you go around like a clock, like I just did, whether you go top, da, 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 da. As long as you don't partner them up until you have 1 on the top, 1 on the bottom, 1 on the left, and 1 on the right. You won't have 2 together until you've got 4, 1 on each side. Yes? For the middle one, for the inner shell, it's like there's a home, okay? So each shell, and this is an imperfect model. We'll get to a better model a little bit later on, but each of these things represent, there's a little room, okay? And there's only 1 room on the first floor, and there's 4 rooms on the second floor, okay? And there's 4 rooms on the third floor. Yes? So when an electron checks in, there's no elevator in the hotel. Where would you like to check into? Would you like to check into the first floor or the second floor? First, because you don't want to walk up with all your baggage, right? So you check in, and here you are. Second electron checks into the hotel. Sorry, that's not sodium. Let's just get rid of that. Where does the second electron want to go? It's going to go on the first floor because it's got lots of baggage. It doesn't want to go there. So now that room is full, okay? Where does the next electron go? Onto the second floor. And now the fourth one still wants to go on the second floor, but is it going to want to share? No. Why would it share when it could go all by itself, right? And so on and so forth until we have all 4 rooms on the second floor with 1 occupant. And now comes in that next electron. Is it going to want to go on the third floor or the second floor? Still the second floor, but now it'll pair up because it has no option of having being a singly occupied room. Okay? And that's what it comes down to. We are not going to spend hardly any time with the Bohr model, but what it does lead us to is it leads us to the Lewis dot structure, the electron dot structure. Did you do those last year in grade 10? Yeah? Okay. So when we look at lithium, the electron dot structure just shows the outer shell, and we do away with the circle. Yes? So what would lithium look like? Just one dot, okay? Does it matter if we put that dot on the side? No, okay? Does it matter if you put that dot on the left? No, you can put it anywhere you want as long as there's just the one dot. How about sodium? Still just one dot. Potassium, what do you think the Lewis structure for potassium is going to be? One dot. And cesium, one dot. And rubidium, one dot. All atoms in the same group have the same essential Lewis dot structure, electron dot structure, okay? So group 1 all have how many valence electrons? 1 valence electron. What makes atoms the most stable? They have to have a full outer shell, or they have to get rid of an electron to have an empty outer shell, which means the next shell in is now full, okay? So a full shell is the most stable. So let's say we were looking at our friend potassium here. Yes, here's potassium. And now we're going to look at, let's see, who have we got? Let's do oxygen. What is the number of electrons in oxygen? Look at your periodic table. Tell your partner how many electrons in oxygen. 8, that's its atomic number. That's how many electrons we have. 1, 2, 3, 4, 5, 6, and then 7, 8. Yes? So what would the Lewis structure for oxygen look like? What would I do? 1, 2, 3, 4, 5, 6 valence electrons. What would the Lewis structure for sulfur look like? Exactly the same, because it is in the same group. Okay. And if I was to have a potassium hanging out here and a sulfur hanging out over here, and in fact, I'm going to make the sulfur, I'm going to make its electrons little X's just to make them look different from potassium's electron. Or actually, I should do oxygen, sorry. Oxygen. Yeah. Doesn't really matter, you can do sulfur. What happens when these two things get together and form a compound? What does potassium want to do with that valence electron? Get rid of it. Yes? So now we have K with a positive charge, and we have O with a negative charge. Is everybody happy? No, what's wrong? Oxygen is unhappy, yes? So who's going to come along? another K. It's going to throw it in there. And so now we will have, instead of just one K, we will have two K's with a plus, and we will have an O. Whoops. You could use a different one. It's not very common. Okay, it does happen. You can end up with like LIKO, but normally not. Okay, yeah. And that would have a 2- charge because it's got those 2 extra electrons. Now, what does a positive do to a negative? They neutralize and they also attract. And what's that attraction called? That is an ionic bond. And if you had one of those, where you had a K plus and an O2 minus and a K plus, what would we call that? A single unit. That would be called a formula unit. And if we had a whole bunch of them forming a 3-dimensional structure, that would be called an ionic crystal lattice, okay? Should we go back to the mole? Have we had enough divergence today? Okay, let's go back to the mole. Okay. Did you learn how to calculate molar mass yet? Yes? So if I were to say to you, why is that so small? There we go. Sorry, I gotta find where this came from. There we go. Okay. If I said to you, what is the molar mass of, I don't know, iron? What would you say? 55. And what is the unit for that? It is grams per mole. Okay, so the unit of molar mass is always grams per 1 mole. Okay. What did I do? Where did I put that? Oh, there we go. Sorry about that. What if I said to you, what is the molar mass? And this question is actually on page 40, but I'm not good. Don't go there. Like, just either watch it or, and if you want to write it down, you can. But if you don't want to write it down, you can just like hang out. This one is on page 40. What is the molar mass? Don't go there. Of CO2. So now we're going from the molar mass of a single element to the molar mass of a, what do we call that when we have 2 elements together? That is called a, is it an ion? It's a molecule, and it is a compound. Yes. Okay, you're getting too fancy for me. Okay, so we have a compound here, and if we want to find the molar mass of a compound, how do you think we would do that? We would add them all up. So we would say I have 1 mole, if I have 1 mole of carbon, that's going to be 12 grams. And if I have 2 moles of oxygen, that's going to be 2 times, what is the molar mass of oxygen? 16 grams, which is 32 grams. And then I can take my 12 and my 32 and add them together, and then I get the total, which would be 44 grams. That is the mass of 1 mole of CO2. How many particles is that the mass of? That is the mass of how many CO2 molecules? (6.02). Yeah. Times 10 to the 23. If you have trouble remembering the 10 to the 23, it's as easy to remember as 1, 2, 3. Okay. Whoa, look at that. Isn't that nice? Now you have to remember the 6.02, but you'll use it so frequently, you'll just know it. Okay. So that is the mass of 6.02 times 10 to the 23 CO2 molecules. So we can say that the mass of 1 mole of CO2 is 44.0 grams, but we would say that the molar mass is 44.0 grams. And what am I missing? Per mole. Okay, so whenever we specifically say the molar mass, we mean molar means per mole. Okay. And guess what? We have 1 unit on top of another unit. What could we use that for? We could use that as a conversion factor. Did you do that with Tyler? I can't remember. Oh, maybe not. That's okay. Okay, I'm going to leave that for a moment. And we're going to go to... We'll let you practice calculating some molar masses over the weekend. Do you want to do one more together? Let's do a complicated one together, shall we? Okay. What is the molar mass of aluminum nitrate? Oh, yeah. And then I'm just gonna pretend that this exists. Hexahydrate. So what's the first thing you need to do to solve this problem? You need to figure out the formula. Aluminum. How do you know that aluminum is +3? Do you guys know your charges on the periodic table? Everything in column 1 is +1. That's because it has 1 valence electron that it will lose. Yes? What is the charge of ions in column 2? +2. Why is that? They have 2 electrons in their valence shell, so they want to lose 2, so they become +2. Now we're going to skip over the transition metals because they do their own funky thing, and we'll learn why later. But now we get to the aluminum group. What charge will those ones be? +3 because why? They have 3 valence electrons, therefore they want to do what with those 3? Lose them. They want to give them away and lose them. I have like a little handout to go along with this sort of idea that I'll get you for next week, but I just could not get it ready this morning, so I didn't. Okay. Now, group 14 doesn't, it's got 4 valence electrons, and they are really like, they don't tend to form ionic compounds. So you can just be like, I don't care what their charge is, okay? When we get down lower, we have metals, and they behave a little bit like transition metals in that they've got more than one charge. Yes? So tin is a metal, and they do their own weird thing. So don't worry about column 4. How about group 18? What charge do elements in group 18 form? 0. Why? They already have a full valence shell. How many valence electrons in group 17? They have 7 valence electrons. Yeah, don't worry about the 17. The 17 includes the ones with the transition metals, and they do their own little thing. So the valence electrons are really only the 7. Okay, we'll talk more about why later. Okay, but just don't worry about the 17. They're just 7. And so if they have 7 valence electrons, what do they want to do? They want to gain an electron, and so their charge will be plus, or sorry, not plus, minus 1. And that means that oxygen has 6 valence electrons, the oxygen group. And so what will its charge be? Minus 2, because it's going to gain 2 electrons. And nitrogen group, how many valence electrons? Group 15 has 5 valence electrons, and so that's going to give you a negative 3 because it wants to gain those 3 electrons. So that takes care of all of those charges. Now we know that aluminum has a charge of positive 3. Okay. Whoops, wrong button. 3 plus. Anyone know the formula for nitrate? NO3. And what is its charge? Negative. And so what is the formula for aluminum nitrate? Al brackets NO3, 3. Okay. And then we have this weird thing, this hexahydrate. What do we do with that? We have how many, what are we adding on to that compound? 6 H2Os. Okay, so 6 for the hexa, and then hydrate means it's got water attached. And what do we put in between? A dot. And what does the dot mean? Loosely attached or bonded. Okay, and what are those kind of loose bonds? What do we call those? Those are our IMFs, our intermolecular forces. Okay, so we have an ionic compound that is loosely bonded to a covalent compound, yes, water, and we have this hydrated salt, and let's find the molar mass for that. So all you have to do is you have to say, I have 1 aluminum. If you like being structured about things, you can do this. You don't have to write out all this work every time, okay? But I'm going to do it just to make life, you know, pretty for you for the moment. How many nitrogens do we have? We have 3. So we have 3 nitrogens. How many oxygen? We have 3 times 3 is 9 oxygen. And we can break up the water. I'm going to give you a little cheat on water. The cheat is to know that water is made of 2 hydrogens, each of which is, so that's going to be 2 times 1.0. right? Because the molar mass of hydrogen is 1. And we have 1 oxygen, and oxygen has a molar mass of 16. It is handy to know that the molar mass of water is 18 grams per mole. If you don't, that's okay. You can add them up individually. Yes, you can be like, you can put in your 2 hydrogens and you can add in your, or sorry, here you have, oh, how many hydrogens do we have? If we were to do it separately, we would have 12 hydrogens and 6 oxygens. Or you can say we have 6 waters. Yes? But that requires you to know that the molar mass of water is 18. Because when you're 18, you can't drink alcohol, you can only drink water. Huh? Okay, that might help you remember it. Okay? So, molar mass of aluminum. So that's going to be 1 times, what's the molar mass of aluminum? 27. And I know it seems silly to write this down, but then everything lines up nicely if I do it this way. Okay? 3 times, what is the molar mass of nitrogen? 14. And so that's going to be, what's 3 times 14? 42. That took way too much effort. And 9 times 16 is 72 times 2 is 144. Is it 144? Yay. And then we have 6 waters. And what's the molar mass of water? 18. How do you remember that? Because when you were 18, you were drinking only water. And quite frankly, having read about the health effects of alcohol, you should actually not be drinking alcohol until you're at least 25. I know that's unreasonable to ask, but I'm going to give my public service announcement here. The later you can actually start drinking, the better for your brain. Because your brain is actually not finished developing until you are probably 25 or so. Okay? Well, it should be, but I mean, here's the fact of the matter is that, you know, you raise it, you lower it, everybody still does it, right? So, you know, what does it really matter? And yeah, yes. It is carcinogenic. Yes, over 1 drink is carcinogenic. So, and you guys know carcinogenic, that means it causes cancer. And it's not going to cause cancer tomorrow or next week, but over the course of a lifetime, you have raised your risk of getting cancer. Does that mean, can you have a person who drinks every day heavily and never gets cancer? You can. Those are statistics, right? Yes. They do notice like trends between what types of cancer, like you'll tend to get throat cancer because it, you know, spends time in the throat, and you'll tend to get liver cancer or other liver diseases as well because the liver processes the alcohol because it's a toxin and it's getting it out of your body, right? So yeah, and I mean, I haven't read the studies per se, but you know what they would do is they would be like, okay, here we have a population of non-drinkers. We're going to look at the rates of cancer within those people. Here we have a population of drinkers. We're going to look at the rates of cancer within that population. And then you have to look at confounding variables like the things like, you know, socioeconomic, you know, level, and what else are you doing? Are you a smoker as well? Those kinds of things. But I'm going to assume that the people who have done the science have done a good job, because there's been a whole lot of it. But, you know, I mean, I could be wrong, right? Because I haven't really read the actual scientific journals. But I feel like it, here's the thing. I know it's unreasonable to say to you, go out there and just never drink, okay? Because that's an unreasonable thing to say to you. What I will say to you is never binge drink, because that does huge damage. Do you know what binge drinking is? That's like one after another, after another, after another, okay? That's the kind that does the worst damage, okay? One way to not binge drink is to, if you have an alcoholic beverage, pour yourself an enormous glass of water and don't have another one until you have finished that enormous glass of water. It will A, slow down the drinking, which will prevent you from, like, you know, you have a drink and then your judgment goes out the window, and then you have another drink and then your judgment gets worse, right? But if you have that glass of water, it gives you some time. Number two, even if you do end up drinking more over the course of the evening, you will at the very least be well hydrated and less hungover the next morning. Yes? But I will say, do try to limit it, because it is just better for your health and better for your brain. Okay, as I said, I have totally given up on it because well, for one thing, I can't even afford the calories at this point. Like, you know, when you're a 50-year-old lady who's 5'2", do you know how many calories I can consume in a day if I don't exercise? 1,200, 1,200 calories. If you have a ginormous burger, that's like all of it in one day. Like, that's my entire day worth of calories. Pardon me? It's like, oh, sucks. Anyway, back to our problem here. 6 times 18, that's 6 times 9 is 54, times 2 is 108. And then we add those all up, 0. That's a 9, plus a 4 is a 13, plus an 8 is an 21. And we carry the 2, and then we have 4 plus 4 is 8, plus 4 is 12, carry the 1, and then there's 3. So the molar mass of aluminum nitrate hexahydrate would be 321 grams per mole. What is the mass of 42, or yeah, 42 moles of Al NO3 3.6 H2O? Now, remember, you have to show your work and you have to show the unit cancellation. Yes? So you do not need to show this next part where you identify that this is your unknown. You don't have to write that down, okay? This is your what? Initial quantity, and this guy here is our conversion factor. You don't need to write that down. You also do not need to write down that in order to find the unknown, it is equal to the initial times the conversion factor. You do not need to write that down. What you would want to write down is that grams of Al NO3 3.6 H2O, I wish I'd chosen a smaller compound, is equal to, right, because that's our unknown there. This is what we would want to write down. And what would we write down next? 42 moles of Al NO3 3.6 H2O times, now what do I need to have on the top and what do I need to have on the bottom? I need to have moles on the bottom and I need to have grams on the top, which is, oh look, it's in the right form already, isn't it? I have 321.0 grams per mole. (42) times 321 is equal to 13482. And what's the unit I have left? Grams. Are we happy with that answer? Yeah, I could write grams of what. I'm a bit tired of writing it, so I'm just not going to right now. But that you make a good point. I should write grams of AL and of blah, blah. I am more concerned about significant figures. Do you remember what the rule is when you multiply with significant figures? Sig figs, multiplying and dividing, you go to the lowest number of sig figs. So how many sig figs in the number 42? Is it infinite or is it 2? I want you to think about a mole. A mole is 6.02 times 10 to the 23, yes? And so if you have 42 of those, do you believe that you have exactly 42 times 6.02 times 10 to the 23 particles? Or do you believe you might be out by a little bit? You might be out by a little bit, yes? So this has 2 sig figs. It is not an exact number. And this one has, how many sig figs does this number over here have? This has 4 sig figs. And so our answer, we need to then round it to 2 sig figs. So that's going to round to 13, yes? Are you guys happy with 13,482 rounding to 13? No, you could write it as 13,000 grams, which would be one way of writing it. And because there is no decimal in the number, those trailing zeros are not significant, okay? What's the other way you could write it? 1.3 times 10 to the 4 grams. Okay, let's figure out what we want to do over the weekend. Okay. What did I have you do last day? Okay, okay. If you are feeling any uncertainty about doing this kind of question, if you need to, like if this was hard or maybe just a little bit uncertain, you would do 5.2D. Otherwise, if you were like, that was cool, you are going to move on to actually, you could just do the questions on page, you could do the video. Otherwise, sorry, this will be another second, pages 45 and 46. And then I'd also like you to try 47 to 49. Yes. Yeah. Okay. This would just be like 45 to 49. There we go.
Why do you want to keep it out?
Oh, I'm good. And then they were like, where are you?
Just grab another one off the. You got it. Yes, it should be. Oh, it's because that's an exact number, that's an exact number, that's an exact number, and that is also an exact, so infinite. Yes. I would, you know what, don't get too worried about it, you're not gonna end up with a question like that like on a real exam, okay? So those are just kind of like fussy little things. You know what I mean? Yeah. AP exam, there are 60 multiple choice questions, and then there's a written response question. Each of those is an hour and a half, I believe. And yeah, so you have in the written response, I think you have 7 questions, and each of them has multiple parts. And so yeah, so there's 3 questions that are worth 10 marks, and then 4 questions that are worth 9 marks, or yeah, 9 marks, I think. Yeah. And as we get further into this course, I'll sort of give you like little, sort of mini ones, just so you can see what it's like. Yeah. Did you have another question?
I just wanted to take a photo.
Oh yeah, go for it. Yeah.
Wait, do you think I could like? Can you like zoom?
You can. You know what? You can like whatever you want to.
Okay. Sure.
Okay. Help yourself.
So you know how for ionic bonds?
Yes. You know what? It is like a molecule, and probably no one is ever going to like get mad at you for calling a formula unit a molecule. Yeah. Okay. It's not really a molecule because molecules are covalently bonded, but you can just say molecule. Yeah.
Yeah. Did you ask if there's a final exam?
I'm so
Should ask her that. Because like, or else my notes, I'll throw them away.
Yes. I'm going to show you the magic button, and actually that reminds me to tell everybody the magic button on Monday, because probably lots of people don't know about it, and it will save you a lot of trouble. Okay. So, if you want to like point out to my this button right here means times 10 to the all of that is in that little and what that does in your calculation all of this is one And then it will multiply by times 10 to the 25. You really want that to still be in the denominator, right? So that will be probably yeah. And then I'm really glad you mentioned that because I'm available.
Personally, no. I guess like some people would, but I have like two other small classes that I'm taking right now, right? So I would have three. Yeah, not for like stress. Yeah. Because I know like most people are also taking baby stats. Yeah. They have like two exams.
You too. You're back. Okay. Yep, that looks good. Yep. No, that looks good. I'm gonna let you do that. I'm gonna clean up. Okay. Do your thing, and then I'll clean up, and then we can like do your thing after you're done. Yes?